Good morning, everyone. Welcome to the CPU scheduling algorithms. So today we are going to talk about the first scheduling algorithm for the CPU, that is the first come, first serve. So the first come, first serve is a non-preemptive scheduling algorithm. So we are going to see some of the numericals to understand the scheduling algorithm of first come, first serve. So if you see here, like I have 4 processes that have been given, and the burst time is defined for me along with the arrival times. So burst time is nothing but the amount of time required by the processes to execute on the CPU. That means how much time does a process require to use the CPU. And then using this FCFS scheduling, we will try to solve this problem and try to answer the completion time, the turnaround time, waiting time, and the response time for all these processes. To calculate this, the formulas for the turnaround time is completion time minus the arrival time. And for the waiting time, the formula is turnaround time minus the burst time. So let's try to see how this FCFS scheduling algorithm will work. So if you see, like the process P1 have arrived at time 0. So you can assume this is some unit interval. So let's try to have the process states by drawing the Gantt chart. So I'm first trying to have at step 0, that is at the first unit of time, at time 0, my process P1 have arrived. So when my process P1 have arrived, so it will try to execute completely. So that means the process P1 will try to utilize the CPU for 2 units of time. So the burst time is 2. That means the process P1 needs 2 units of time of the CPU. That means he needs the CPU for 2 minutes, 2 seconds. You can say something like that. So the P1 have entered in the queue at 0, and then it is running for 2 seconds or 2 units of time. That is from 0 to 2, P1 have executed. Now, between this execution, in between, like if you see at arrival time 1, process 2 have actually arrived. That means somewhere in between, process 2 have already arrived. So after the completion of the process 1, we will try to execute process 2. So the process 2 will now get executed here. So how long will it get executed? The process P2. So the process P2 also needs 2 units of time of CPU for getting executed. So it will completely execute this process. So here is 4. That is 2 plus 2 is equals to 4. So totally on this Gantt chart, like we are going to follow this time here. Now, in between this time, so do we have any new process that have come? So if you see at the next process, the process 3 will actually arrive at 5 unit of time. So, but the 5 unit of time has not happened. So the CPU will be running, and here it will be 5. That means this state is actually the ideal state of CPU. That means the CPU have not done any useful or productive work. So now at P5, now at the 5th interval of time, our process P3 have arrived here. So when P3 have arrived, so P3 will execute its process. So the P3 will be executing here. So how long the P3 need to execute? So P3 actually needs the CPU for 3 seconds. So it will try to add here. So it will execute for 3 seconds. So 5 plus 3 is 8. So we will just have here the execution. Now, when the process P3 was executing between 5 unit of time to 8 unit of time, the process P4 have already arrived. When did it arrive? It arrived at 6th unit of time. Somewhere in here, process P4 actually got arrived. So now P4 will get executed. So the P4 will be executing here. And how long will the P4 execute? So P4 will execute for 4 units of time. So that means 8 plus 4 is 12. So once you have completed drawing your Gantt chart, using this Gantt chart, you can actually answer the completion time column. So if you see like the process P1, when did the process P1 get completed? So you have to see where is P1. So P1 is here and P1 got completed at time interval of 2. So at 2 units of time, it was completed. So I will just write 2 for process P1. How about for process P2? Process P2 got completed on 4th unit of time. So I will write 4. So remember, you have to take the time on the right-hand side and not from the left-hand side. So after that, the process 3 have completed at 8 and then process 4 have completed at 12. If I want to calculate the turnaround time, so turnaround time, the formula is completion time minus the arrival time. So 2 minus 0 for the process 1 will be 2. And then 4 minus 1 will be 3 for process 2. For process 3, it will be 8 minus 5, again 3. And then 12 minus 6 will be the turnaround time for your process 4. Similarly, you can calculate the waiting time. The waiting time is turnaround time minus the burst time. So turnaround time for the process 1 is 2. 2 minus 2 is equals to 0. So if you calculate this, you will get all the waiting time and the response time. If you need to calculate the response time, so what is the formula? The response time is the time at which the process gets the CPU for the first time minus the arrival time. So at P1, when was the first time the P1 process got the CPU? It got the CPU at the 0th interval of time. So 0 minus the arrival time of process 1 is 0. So the response time will be 0. If you notice one thing here, the waiting time and the response time for both the columns, the values will come the same because we are operating in the mode of non-preemption. So usually in non-preemption, we will try to have the waiting time and response time the same. So let me go take you to the next slide. So I have already calculated all the values for the turnaround time, waiting time, and the response time. So if you see, the waiting time and the response time remains the same. So this is happening because it's the non-preemptive mode. So the response time will be different from the waiting time when we are using a mode of preemptive. So we will talk about that in the next scheduling algorithm. Now, one of the problems with the first come, first serve scheduling algorithm is the Conway effect. So what do I mean by Conway effect? So usually, whenever you have a big process, suppose here, instead of process P1 having the burst time as 2, suppose the process P1 have a burst time of 20. Instead of 2, it have 20 burst time. So you can imagine the process P1 will first execute for a very long duration of time, and then the other processes will be executed. So here we are trying to have some kind of Conway effect where the CPU is utilized for a longer duration for one of the process, and the shorter processes of shorter jobs have to wait in queue for the long process to complete. So this is the drawback of your first come, first serve scheduling algorithm. So we'll try to see in the next class shortest remaining time algorithm.